Hello everyone. I'm going to talk about research analysis. The title is supporting a dynamic bandwidth and adjustment based on a virtual transport link in software-defined IP over optical networks. I'm William Cho. This is my index about this paper. The first one is how to they propose their analysis and what is PTL and also simulation results, and about the final one is conclusion. In this paper, they propose a concept called virtual transport link (VTL), which is to support dynamic link aggregation in software-defined IP over optical networks. They are focusing on optical networks, and also they introduce a BLF-based dynamic bandwidth adjustment, which is a VDL-DBA method, and is proposed for improving resource utilization and also for simplifying service provision. So now I'm going to talk about what is VTL. VTL is a virtual transport link. It is a virtual connector to bind end-to-end services and also transport resources together, which can achieve software-defined and dynamic aggregation. So it also support transport all kind of transport resources such as an optical transport network (OTN), WDN, and also elastic optical network (EON). And VTL is composed of two parts: physical transport channel and software configuration. You can see in this virtual transport link topology. First one, they establish a transport channel on the based on optical network, and also number two is they configure the group entries into the packet layer, which is related to the networking infrastructure. And final three is they save the mapping between the group entries and transport channels. You can see in this topology how it work in a virtual transport link. This is infrastructure of the packet over optical transport network. You can see it's the optical transport network, and you can also see the packet network, and they are controlled by an SDION controller, which is a software-defined IP over the optical network. And we can also see the customer service requests and also SDAA. SDAA is a smart service aware application, and in this case, in the IB router switches, we have data centers. Also, we have enterprise end-to-end connection. So in this case, we have to use optical transport network, and also they are using SDION controller to adjust the bandwidth and traffic allocation. This is a comparison between SSBA, SABA, and VDBA. SSBA means studied and separated bandwidth allocation, and SABA means static and aggregated bandwidth allocation. VDBA is a virtual transport link dynamic bandwidth allocation with service aware. In this case, in the figure one, you can see it cannot save traffic allocation, but in the figure 2, it saved 20% of the traffic allocation. But when they use the VDBA, it can save around 40% of the traffic allocation. So it is better than other two methods in this paper. This is a performing VDL-DBA bandwidth allocation and adjustment in a VDL with high priority. You can see the each service means the traffic with high priority or medium priority, and duty services mean traffic with low priority or priority. So they have 4 rules based on the device, and this video DVA bandwidth will adjust the bandwidth allocation and adjustment based on the traffic and user based on the user. This is the algorithm, and this is a topology that they used in their test bed, and is a final result. You can see around the 4 minutes the output port is tremendous amount of traffic is flowing in the output port 1, and in output port 2 no traffic is flowing. So after 1 minute later, and then also they use a video DVA traffic, so this algorithm will adjust the traffic between the output port 1 and port 2. So you can see that now it adjusts the traffic between the output port 1 and port 2, so they have the same amount of traffic flowing between them. This is the two topology they tested about video DBL. The first one is an SFNet topology, and the second one is COS239 topology. Also they have occupying transport resources for based on two topologies, and the first one is, you can see that occupying resources are lower than SSPA and SAPL, and but in resource utilization BDL-DB is the better than other two methods. And the final result, simulation result 2, is a block probability and resource utilization simulation results based on these two topologies. So you can see block probability on these two base topology. You can see BDA-DB is the better than other two methods, and also the resource utilization. You can see VDL-DB method is the best in base among other two methods. This is a resource utilization of each transport for traffic with high priority based on two topologies. But in this case, in this paper, they provide the second topology result is better than the first topology, because you can see the resource utilization is near almost 100 of the bandwidth. But in this case, resource utilization is sometimes based on half of the bandwidth. It's not good performance. But the second topology, they got a good performance in a video DBL. In the conclusion, I would say they said that video DBA method efficiently improves in the resource utilization of the service provider network, and also they reduce the block probability. And so carrier, maybe service provider, can achieve a high resource utilization, and also they can provide pay-as-you-go services to customer based on this method. From my point of view, this research paper is a strong work, but it has detailed information about how is it work and how to handle the fuzzy nature of the network. And they also need a security part in this paper, in my opinion. This is my research analysis on the budget transport link on the optical network. Thank you for your attention.